Next up, we have our very own Phil Edholm. Phil is doing part two of scratch building an NMRA contest winner. So, in addition to his technical skills in supporting the show, Phil is also an accomplished scratch builder. And this is a very unique uh, construction method. So, without further uh, introduction, Phil, go ahead.
Super. Thanks, Tom. So I'm going to buzz very quickly through this because otherwise Tom's going to yell at me. So we talked a little bit about the basis of the building. So let me go through it this a little bit further. So, like I said, when I started building this model, I've gotten to the point where I didn't like putting things in trailers. They tend to get banged around a lot. As I thought about how to build buildings and take them off, I decided this concept of doing an acrylic box made a lot of sense. So I actually built all three buildings that go on the layout were originally built using acrylic boxes or started using acrylic boxes. So on the left at the bottom, you see two buildings on one side of the layout. On the right, you see the Hovden cannery that's at the other end. Um, this actually is a great technique. This is 1/8 scale and O scale, 1/8 inch acrylic. It's just the standard acrylic you get at Tap Plastics. You can do an HO 1/16 works just fine. I think for the 1/8 has a little bit better rigidity. Basically, the way I did this is I cut almost all the major pieces on my table saw. The key with cutting this is you just want to take a really good sharp blade and set the blade height just minimally above the plastic. So actually what I do is I take a piece of plastic, scrap plastic that's the thickness, I start cutting it and then I run the blade up so it just breaks the surface. Um, the problem with cutting acrylic is if the blade comes down on the acrylic, it actually can shatter it and create cracks. If it's coming through and shaving away the plastic and you push it smoothly and gently through, you don't get cracking around with the cut points. And then I have this scroll saw, which actually I think my parents gave me when I was young, so it must be very old. And actually used it to cut the joints out where I couldn't use the table saw. I used some of these brass building jacks to hold the walls in place, and then just use the acrylic glue that you get from Tap Plastics. I bought the little dispenser you see on the top right photo there, and just after you put them together, hold them together, just drip that on there, run it down. You don't really need to worry about whether it gets on a little bit or not. You're not trying to make a clear box there. You just don't want to get it over to where you put the windows. So the key then, the next step is you've actually got to sheath this thing in wood. So what I did was I did the outside first. This is Northeastern lumber. It's their board and batten siding on the outside. And as you can see on the upper left, I just put that on. I cut the pieces and I decided where I wanted the windows. The windows are cut through the wood and then the wood is glued on. And I did that using epoxy. So I got one of those things where it's two tubes and you squeeze it and you can squeeze out a little batch of epoxy and put it on the wood, spread it all around. Just make sure where the windows are, you stay back about a quarter of an inch so that when you push it down, you don't get any squishing into the window areas. And again, the windows were not cut out here. What you're going to see in a moment is you're actually looking through the 1/8 inch acrylic when you look into the building. Once I got the outside done, then I did the inside and I just cut it to match. And this was all cut just using a X-Acto knife and a straight edge. What you can see on the bottom is that I have now painted the outside has been done in red. This was done with stains. It was actually done with red stains and then some red craft paints mixed in with the stains. One of the cool things about doing things on acrylic is if you get it on it, it doesn't matter. You can just clean it off with alcohol. Alcohol has no impact whatsoever on acrylic. So cleanup is really easy. Um, the center picture, what you can see on the bottom, I put a track in the middle of this. When I looked at the thickness of the ties to get up for the floor being level, I found the acrylic was about the right thickness. And I put that down, and then I added a couple of rails in, which were ACC'd across, which were for the transfer out onto the dock, which would be the bottom on that picture. The right picture is just an interesting thought. This is how I got power up to the roof. Those are some brass shoes I got somewhere in estate sale, and I just basically ground them down to match the roof shape, glued them into the acrylic, and then the wood was cut around them. and they've got a brass rod that runs down through the floor, and you kind of see the slot in the center picture there that's cut for the rod. So when I got done, this is what it looks like. Now the windows, the way the windows were done is I took the window frames, these are just tissue window frames, and I sanded them down until the sides of the frames were the same level as the main mullions, which is the lower ones. It turns out there's a slight gap then between the upper mullions and the acrylic, but it turns out it's so small it's virtually impossible to see. And when you look through it and you look at this from this point, you really have no way of telling that this is not that kind of traditional scratch built structure. Then on the inside, after I got the wood was done, I layered in what would be the framing, and the framing was added on the inside of the wall. So that starts off with, you can see here across, there are some horizontal pieces to hold the wood in place. And the framing here, I was actually up in Sacramento and the old CP Southern Pacific shops. If you go to the very back of the shops, which were built in the 1860s, it turned out what they were used to building was tunnel portals, and they framed the whole building looking like tunnel portals. So I actually tried to replicate that in the design of this in terms of the supports, etc. I'm not going to talk a lot about the interior. Everybody kind of understands this is all just basically scratch built pieces with little pieces of styrene with NBWs on them for this overhead conveyor system that moves from the interior tracks to the transfer tracks, and then a bunch of extra pieces I won't talk to. The one thing that's interesting about this is that if you look at the pictures of the building, you'll notice that the walls are an 1/8 thick plus plastic on either side. So by the time you get done, they're not quite 3/8 thick, but they're actually fairly thick. They're not to scale. There are a couple of places you would notice that. And one is here on the left. If you look at the picture on the left, notice right here, this is actually the wall. So you see the framing here, the door here, and the wall here. But quite frankly, until I pointed that out, for most people, you would never notice it. So even though the walls themselves are thicker than they normally would be with like 1-inch siding, in most cases, it's almost impossible to see. The other thing that's very interesting about this is that when you look in the building, you're actually looking through that 1/8 inch acrylic. So all of these pictures, you can see how clear it is when you look through it. The acrylic is incredibly clear, and you don't get any distortion because of the depth on it. What's really interesting is when you look at the building and you look in, if you look right here, excuse me, let me go back a picture. If you look right here at the bottom of this window, you notice you can see where I cut the board that's on the inside here. But when you look at that same window in this picture where you're looking at the whole building, it's almost impossible to notice it when you first off look at it. So it really turns out you can get very clean windows to look through without having to put windows and window frames in, and it just becomes part of the overall building. The roof was built the same way, 2 pieces of acrylic. What I did was I put these gussets in right here to tie the 2 pieces together. Turns out those were very nice because you saw that shoe earlier. By drilling a hole in these and wrapping a piece of wire around them, when they slide down in, the wire slides onto this shoe, and that's how you get the power to the lights. As I was thinking about building this roof, the roof system, I decided I needed trusses. When you looked in, not having trusses up there wouldn't look good as you looked in the side of the building. And I had bought a 3D printer, as I said, so I decided I should 3D print the roof pieces. So these are all 3D printed. Turns out for them, these are just paper gussets. They're literally cut out of black paper and glued on. And these are a couple of troughs that run 4 of these lights. These are those O-scale lights you can get from We Honest on eBay. And I think there are like 10 of them or $11 or something like that. Very nice. And this is actually just kind of a channel, and the lights run through. And again, starts on one end, comes in, it's got a resistor, 4 lights, runs out the other end. When you drop the roof in on the building, the lights come on. So basically, I was sitting there, I was building this building on the left, and I was looking at the one on the right, which was the same concept, and I was intending to do the same way. And after I'd printed those 3D roof, the trusses here in 3D printer, it hit me, why don't I think about making that building out of the same concept using 3D printing for the actual framing of the walls? So that led me to this. This is actually the pictures of the building. This is the only good picture I've got looking back at Moss Landing. And these were the warehouses they had there. So blowing that up, you can see kind of what it looks like shape-wise. So I designed the building essentially to match that design. So this was my original design. It's 20 by 8 inches. Broke it up into some pieces, put some doors in it because I wanted to be able to get on and off to the dock, the pier that's sitting next to it. In order to print this, you can't. The printer bed is about 8 inches. It's 220 millimeters. So you really can only have about an 8-inch piece. So if you take 20 inches and you break it up into two 6-inch pieces and an 8-inch piece in the middle, you can actually do the whole wall in 3 prints. So what I did was actually at this point took the design that I had and translated it into using I use FreeCAD, using FreeCAD to actually design the walls. So what you see here on this picture is these are actually the printed walls, 3D printed framing for each of these sections. And the way that was done, just very quickly, the trusses are on 8-foot centers, the posts are on 4-foot centers, the windows and doors and the heights and all that was done in the CAD system. Didn't really worry about trying to do a really accurate drawing before I went into the CAD system. So this is a truss wall or a wall print in CAD. So what you can see here is there's the top plate, bottom plate. There are essentially where there are trusses here, you'll see that there are 6x6 beams. Essentially, these are 6.6 millimeter or 6.3 millimeters. So it's 6 inches in O scale. These are 6-inch by 3-inch pieces where you don't have a post on the top. This end here on the wall where you actually tie to another wall piece is actually 3 inches thick and then they glue together. You notice one of the things I did was I put these holes in for alignment. One of the really cool things in 3D printing, when you glue things together, and I used epoxy to glue those together, you can put in a little piece of, I just use a piece of copper wire that I cut off, or you use brass rod. When you make these holes, you can put them in at the top and the bottom because they're absolutely aligned because you're doing it in CAD. When you put the two pieces together, they actually handle your alignment for you. What you notice is I actually embedded here, and it only goes about halfway through the wall, a diagonal. It turns out I'll show you in a future, the next version that I did of this, not for this building, for another building. I decided it was better to put this on the face of the framing. For this one, though, I had embedded it. And finally, I for the roof trusses, I decided had to have a way to put those on. So I added these little blocks on the top and then ran a hole through all of them so that you could actually clip the trusses in place. I'm not going to go through this in detail, but these were the steps in FreeCAD, which is typical for any CAD system. Obviously, if you use Tinkercad, you might do this a little bit differently. But basically, you start off by creating a panel that I carved out pieces. You could carve out just the center and do all of the other framing pieces as individual pieces and put them in place. But I did it as actually removing the material to what I wanted. And then where the windows were, I added in these little pieces above and below the windows and a few other pieces, and then the diagonal. And then finally, those top pieces across the top. So it's essentially, as anything else in CAD, it's a matter of deconstructing the thing into a process to get you there. And in the end, that's what you get out of the CAD system. This then goes through I use Cura, which is the slicer that takes the CAD image and turns it into something to be printed. It's going to be printed on a filament printer. This is not resin. So you'll notice what I did was I printed this with that interior diagonal down. Gives you a nice finish. It was printed, I think, at about 1.2, if I remember, about 1.2 millimeters on the dynamic quality. So it's very much a pretty traditional print that prints on your print beds. So you can see that's 6 inches wide, and you see the print bed's a little bit wider because it's actually about 8 inches. So that's really all I wanted to get to tonight. We're going to focus next week on how you take that and basically assemble it, put it together, and then the real biggie is how you paint and finish all the pieces so that they can be assembled. Anyway, back to you, Tom.
I would think
Phil, this is Bob Gelmacher. I got a question for you. Where the wood pieces meet, did you create any slight indentations to represent joints?
No, I didn't. I really
Okay.
didn't. Though it turns out you actually can, but I wouldn't try to do it in the plastic. One of the things I'm going to talk about when I talk about finishing is one of the keys to finishing this stuff with wood is you spray it with about 4 coats of filler primer. So automotive filler primer you can buy at Home Depot. It's basically a gray primer that's got big, almost dusty particles in it.
Yeah.
And it's designed so you spray it on your car where you got a scratch and you can sand it smooth and it'll fill the scratch hole in. If you spray something with about 4 coats of that, you build up essentially a layer of stuff and you can scrape it off with a razor saw. And I'll show you that in the next session.
Okay.
If you wanted to, you could go to the top of the walls and scribe a piece across there. Just use an X-Acto knife to turn it over backwards, so you're not using the sharp side, you're using the back of the point, and you could scratch a joint across there, and you could actually see it.
Hmm.
Generally, I don't think you see that many
Unknown
of those
color.
things, but anyway, that's how I would do it.
Well,
Okay,
thank you.
good. Thanks.
Any other questions for Phil? Well, thank you very
Thanks
much for
again.